Hi students, welcome to physics class. In this video, we are going to discuss about relative velocity. Relative velocity. In this video, we are going to discuss about relative velocity. Now, go for the discussion. Consider two objects A and B. A and B moving uniformly with average velocity with average velocity velocities VA and VB in one dimension in one dimension comma with reference to the ground, that is, take this is initial point, this is final point. Consider it is XA, not XA of 0. Here the velocity is VA. It is XA of t. If take here the same distance, here is XB of 0, the velocity is here VB, and here XB of t. Now consider here it is velocity V1 in positive x direction, and also V2 is also in positive x direction. This is object 1. This is object 2. If XA of 0 and XB of 0 are positions of objects positions of objects A and B at a time small t is equal to 0. Their positions xa of t and xb of t at a time small t are given by xa of t is equal to xa of 0 plus VAT. Consider this is equation number 1. This is also distance. That means final distance. This is initial distance. Gives distance of particle A. Similarly, xb of t is equal to xb of 0 plus VBT. Consider this is equation number 2. Here xa of t is equal to xa of 0 plus VA of t. xb of t is equal to xb of 0 plus VBT. Consider this is equation number 2. Therefore, the displacement from object A to object B is given by therefore x BA of t is equal to xb of t minus xa of t, that is equal to x b of 0 plus v b of t minus xa of 0 plus VA of t, that is equal to xb of 0 minus xa of 0 plus VB of t minus VA of t. Consider this is equation number 2 or this is equation number 3. Therefore, the velocity of object, capital B relative to object A, is given by VBA is equal to VB minus VA. Once again, I am repeating the point. The velocity of object B relative to object A is given by VBA is equal to VB minus VA. Therefore, the velocity of capital A relative to B is given by VAB is equal to VA minus VB. Therefore, the velocity of object B relative to object A is given by VBA is equal to VB minus VA. Consider this is equation number A. Therefore, the velocity of object A relative to object B is given by VAB is equal to VA minus VB. Consider this is equation number B. Now, from equation A and equation number B, from equation number from equation A and B, VBA is equal to minus VAB. This is important. This is important. From this one we know that VBA is equal minus VAB. Consider this is equation number C. So this is very very important. Now we are going to discuss some special cases. Point number 1. If VB is equal to VA, then VB minus VA is equal to 0. Therefore, VBA is equal to 0 or VAB is equal to 0. That means the two objects at a constant distance their position time graph are straight lines. Straight lines parallel to each other. Once again I am repeating this point. If VB is equal to VA, then VB minus VA is equal to 0. That means VBA is equal to 0 or else VAB is equal to 0. That means the two objects at a constant distance, their position time graphs are straight lines parallel to each other. Now take x-axis. On the positive x-axis we took time, the time in the form of seconds. Take y-axis. In the y-axis we took distance or displacement, that is positive y-axis. It is origin. If I draw two lines like this, two parallel lines, this is VB, this one is VA. What we understood here? VBA is equal to 0. That is equal to constant. constant velocity. Similarly, V AB is equal to 0. That is called constant velocity. Constant velocity. VBA is equal to 0, that is called constant velocity. VAB is equal to 0, that is called constant velocity. Therefore, VAB is equal to VBA. Therefore, position, that means position time, time graph, position time graphs of two objects with equal velocities. With equal velocities. Now we are going to discuss point number 2. Point number 2. If VA is equal, VA greater than VB. If VA greater than VB, then VB minus VA is equal to negative value. That means VBA is equal to negative value. Therefore, VAB is equal to positive value. One is steeper. One is steeper than the other. And they meet at a common point. Now, I would like to draw a diagram to make you understand. That is, now take x-axis, take y-axis. On y-axis, we took distance. On x-axis, we took time. This is origin O. Now, one is already started here and move like this. Consider it is 20 distance. Now consider it is the 40 distance. Now here one object moved and travel like this. One object moved and it is approximately travel like this. Okay, this is not parallel to x-axis. So consider this point is common point. Consider it is VA. Consider it is VB. Now here VA is equal to VA. B is equal to positive. Similarly, VBA is equal to negative. We have to remember this point. Okay, now what this graph shows, now go for discussion. Position, time graph, time graphs of two objects with unequal velocities comma showing time of meeting. Once again, the above graph what indicate? Position time graphs of two objects with unequal velocities showing time of meeting. Point number 3. Suppose VA and VB are opposite signs. Therefore, VA is equal to minus VB or VB is equal to minus VA. Now take two cases. Case number A. What is case number A? If VBA is equal to minus VB minus VA. Therefore, VBA is equal to VB minus of VA. At the same time, VBA is equal to minus of VB plus VA. That means VBA is equal to VB plus VA. Once again, VBA is equal to VB plus VA. Now, point case number B in point number 3. Point B. VAB is equal to VA minus of VB. Therefore, VAB is equal to minus VA minus VB. Therefore, VAB is equal to VA plus VB. Therefore, VAB is equal to minus of VA plus VB. That is what we understood, the magnitude of VBA or VAB is greater than the magnitude of velocity of A or B. Once again, I am repeating this point. What we understood from this one, the magnitude of VBA or VAB is greater than the magnitude of velocity of A or B. Now, in this case, the magnitude of VBA or VAB is greater than the magnitude of velocity of A or B. So what is meaning for that one? That is a person sitting on either of the two, comma, the other train, seems to go very fast. Once again, I am repeating this point. A person sitting on either of the two, the other train seems to go very fast. Now, I would like to draw a diagram for this statement. Now, I took y-axis and x-axis. On x-axis, positive x-axis, I took time. That time is in the seconds. Here I took distance, that is in meters. Now I took a train which is moving like this. Consider its velocity is Vb. Now I have to consider this one as, now consider another train which is moving like this. Consider its velocity is Va. Here we also called it as VAB because this is compared with this one. Now this train or this object we are comparing with this one. Therefore we have to write it as VBA. Okay. Now this is about the diagram. This indicates that at a position both are at same point. This indicates that the position time graph of two objects with velocities in a opposite direction and meeting at any one point. Meeting at any one point. This is one direction, this is another direction. Now, I would like to give a statement about this diagram. Now, position time graph, position time graph of two objects with velocities in opposite direction. In opposite direction. Showing the time of meeting. Okay, once again, position time graph of two objects with velocities in opposite directions showing the time of meeting. So, this is about relative velocity. My dear students, I hope you understood what is about relative velocity and special cases. So, thank you. Very much for watching this video. Thank you very much for watching this video. Thank you.